Hello, section Training a Model using TensorFlow. In this video, working with TensorFlow, we will cover TensorFlow framework. Let's start with looking into deep learning frameworks. Deep learning frameworks are frameworks which are focused on defining graph of neural network, organizing training and prediction of deep learning models, and importing and exporting pre-trained neural networks. The main advantage of using framework is that you can use predefined layers, metrics, loss functions, as well as train it in a simple way. Also, if the framework is popular, then usually there are a lot of pre-trained neural networks and code examples which would allow you to easily make first prototypes for the task. There are two main types of neural networks frameworks, with static or dynamic graph. Keras, ImageNet, and TensorFlow version 1 have static graph, which means that graph is defined as static configuration file or text, which you have to define before execution. Static graphs provide great performance in terms of training speed, and TensorPod provides a great way of visualizing results. These features make it more popular for industrial applications. PyTorch and TensorFlow version 2 have dynamic graphs, which means that graph is defined as code and its performance can change during execution. Dynamic graphs support more complex logic compared to static graphs and also easier to debug as you can get intermediate values of model during training. These factors make this kind of frameworks more popular among research community. Let's look more into the development comparison between frameworks. TensorFlow is more focused on working on multiple platforms, while also being able to work with C++ for improved performance. Also, TensorFlow Serving provides easy start with creating REST API for the Deep Learning API. PyTorch is focused on exporting models using ONNX format, so that it can be used by other frameworks on different platforms. Also, PyTorch can work great for training as it has good implementation of data parallelism. Let's look at the example definitions of neural network based on Keras and TensorFlow 2.0. Let's start with Keras. As you can see, the network is defined as a sequence of layers where we define each layer separately. While it is very concise and simple, debugging or adding complex logic for this kind of network may be hard as it is not very simple to access intermediate network weight numbers. Now let's take a look at the same network defined using TensorFlow 2.0. As you can see, it is defined more like a code and it definitely doesn't look as simple as Keras example. At the same time, this kind of notation would allow us to easily access intermediate network weights, either to organize complex flow or to troubleshoot training. Although training neural network may require big processing power and a lot of data, deploying can be done using simple CPU. In that way, we can say that deploying deep learning model is close to using external libraries in your code. Secondly, there is a large community of people and companies open source their pre-trained neural networks, meaning you can freely use them for your applications. There are two main cases where using pre-trained neural network can be extremely convenient. First case is when your task was already solved. For example, if you want to conduct image captioning or text classification, then you can use already existing neural networks. Second case is when your task is fairly different from what has been done before, but it is close. Then you can fine-tune pre-trained models for your specific task. TensorFlow currently is the most popular framework for deep learning. It has a very large community of people and a lot of people share the models they have trained. Most companies which are using neural networks in their production environment are using TensorFlow framework. Thank you for listening. This concludes the end of this video.